Hey, welcome back to another video for the Linux series. I know it's a bit weird seeing the Windows interface, and this is supposed to be the Linux series. It'll make sense in due time. So this video is going to be covering storage management concepts. And one of the exercises, at least the first initial one, is I'm going to create a partition on the disk drive, right? So I'm going to use Secure Shell to connect to another server, which is a Linux server. Alma, I believe, from the current server that I'm on now, which is utilizing the Windows OS, of course, as you can see. And then I'll use the fdisk and the gdisk commands to create different partitions on the device. So let's get started with heading to the PowerShell. Just go here. All right, let's clear the screen. Perfect. All right, so now I'm going to do Secure Shell Administrator at 192.168.01. Yes. Okay, perfect. All right, so what I did was I used the secure shell command to connect to the Linux server. So now we see the PLAB server 01 servers, at least a prompt for it, right? Meaning that I am officially connected. So let's take a look at a few things now that we're here. All right, so now it's listing the block storage. So what I'm looking for in this case, looks like I found it for SDA and the partitions created on it, which just looks like SDA 1, 2, and 3, which are the partitions, right? And I also want to take a look at SDB and SDC, which are also disks, but no partition for them are shown. Let's clear this out again. All right, so now I'm going to create partitions on a disk. So let's start with this one here. All right, so now that I'm in the root, so what I did initially, right, the sudo su command, I executed that so I can run the commands as a root user, as you can see where I'm prompted at now, as far as the labeling. But let's start with the fdisk, and let's do SDA. All right, so now what we can see from the output is a list of the existing partitions on the Linux system. And if we notice, the SDA hard drive has 3 partitions, right, as we can see here, right? And now if a partition is created on a disk that has a partition, any existing data typically may not be recoverable as it will be overwritten by a new partition. So let's do another command here. Okay. All right, perfect. So looks like there's no partitions that exist on the SDB hard drive, but that's fine. Just going to use fdisk now to create an MBR partition on the SDB drive. So let's do this one here, all right? And need a little bit of help. All right, and let's do, and so I can see, okay, the partition default is 1. Okay, that's fine. Leave it at the default. And just like my cell service, it's 5G. We should this up a bit more, right? And here. Like it wants to take its time. Okay, last sector, that's fine. Not sure what's going on here. Okay, perfect. So let's take a look again. All right. All right, so I see that the two partitions, SDB1 and SDB2, are created on the SDB drive, just like I wanted. All right, perfect. So let's now start with the G disk. Third one here. If it's not present, okay, that's fine. Put that to the bottom. There, same here. G. Okay, perfect. Yep. This is fine. Okay. Let's put that here. Um, okay, shouldn't be accent. Oh, there it is. Perfect. Let's take a look again. Now we see SDC now has its partitions created successfully on here. All right, so now we're going to do something else here really quick. Okay, perfect. So with the command I just entered, it created a swap space of 5 GIB on the SDC drive. So now let's take a look at what we're seeing here. Okay. Okay, everything looks like it's working pretty well. All right, so now I'm going to create a file system on a disk drive. So I'm just going to prepare a drive for use and then create different file systems on the existing partition. Then I'm going to create labels for the newly created file system. So first, let's clear this out. Put this all out, all right? And now let's take a look this way instead. So there's nothing listed. Let's see. Under the file system type column for SDB1, right? And SDB2 as well. But I can also see that the SDC1 partition is of the swap, the FS type. I created in the previous thing that I did here. So let's get some help here. Okay, so it looks like it. What I did was I created a new file system on a Linux device, and the help parameter that I just used just listed the options that can be used with the in conjunction with the mkfs command. So I'm going to do mkfs t extended 4 1. Right, perfect. So now it just created the ext4 file system on the SDB1 partition. And we're actually going to take a look at that. There it is. We can see it here. All right, so it's now been successfully created on the SDB1 partition. Now I'm going to create an XFS file system on a partition now. All right, so first let's clear this out. All right, so KFS T XFS. All right. Perfect. So now this just created the XFS file system on the SDB2 partition. And again, to take a look, just to confirm, you can see it here. Perfect. Nice. So it's been successfully created on the SDBP2 partition. So lastly, at least for this exercise, I'm going to create some labels for ext4 and XFS for those file systems, right? So let's clear this up. And now I'm going to do some E2 label for for SDB1, storage 1. And making sure there's no issues. All right, so it just created the label storage 1 for the SDB1 partition and the ext4 file system also. So nonetheless, I can just go ahead and continue on with my next command here. Okay, perfect. So it has a new label, and it just created the label storage and the number 2 for the SDB2 partition, the XFS file system as well. Of course, let's take a look here. Okay, perfect. So the labels have been successfully created. All right, let's see XFS here. See storage 2, storage 1. See the label. Just to note that this is the label. All right, perfect. So lastly, my last exercise, I'm going to mount a file system on a disk drive. So I'm just going to mount them as far as what was created earlier on a disk drive so that the Linux system can have access to them. So first, I'm just going to create a temporary file system mount point. I'm going to make a directory. And then, let's see, storage 1. And then I'm just going to do the same here, right? So it just created mount points. Again, they're named, as you can see here, storage 1 and storage 2. So I'm going to tell them to mount. Okay. Now this time it's going to be S and oh, wait a minute. Perfect. There we go. So it just mounted the ext4 and the XFS file systems onto the storage 1 and storage 2 directories, which are again the mount points that I mentioned. And we're going to double check it once we take a look at the list here. All right. So we can see that both file systems are successfully mounted in their respective directories. Well, I could have used another type of command to the df subtraction sign h command for the mount commands to verify if the file systems have been mounted. But nonetheless, we can see here. So I'm just going to umount and SDB1. All right, then same SDB2. Right. And it's good, just pretty much just remove the amount that was created for the ext4 and XFS file system. And then just to verify, I'm going to bring this back up here. All right. Perfect. All right, so we can see that the mount has been removed. And if you want to verify it here, just take a look here. You can take a look here as well. You can see the storage 1, storage 2 for the mount point. And now we have nothing here. It's all in the clear. So the swap on command, so I'm going to use, it's just going to mount the swap file on SDC1. So let's showcase that. Okay, perfect. So it did that, and then let's double check, of course. All right. I'll highlight it. Right. So the swap file is now mounted successfully on SDC1. You can see here. Right. So lastly, I'm just going to create a persistent file system mount point. So before I do that, let's clear this out. All right, so I'm just going to use the mount command to create a persistent file system mount point. So just going to do a sudo edit. Then that's that. Perfect. All right, so now in this file, I'm just going to modify the fstab file to create a persistent mount point as I mentioned, and I'm just going to, let's see, do this here. There it is. Okay, perfect. So now that I got those in there, um, so what it is for the options parameter, the defaults indicate the default mount option to be used, and RO is for read only, right? And the dump parameter that I used is to specify the backup operation where 0 indicates no backup, right? And 1 will back up the partition. Now the path parameter is used to check the order of the file system. And if it's set to 0, which it is, the order will not be checked. So now I'm just going to save the file. Okay, there we go. Then I'm going to exit. So now I'm back at the terminal. Get this out the way here. All right, perfect. So now let's enter in my next command here. Start mounting. All right, because I just activated the changes made to the fstab file. And now I'm going to do the other command I mentioned earlier, df subtraction h, right? And now I notice that the SDB1 and SDB2 are now mounted. You can see here, right? Because it says mounted on. It shows us what it's mounted on. So let's exit here. Let's exit the Linux server as well. And I can close this out and close out the video. So just for a brief recap, I went over storage management concepts for Linux. I did that by way of the Windows OS, but logging on the Windows OS, logging onto a Linux server from Windows OS by way of secure shell, right? And just for a brief recap, again, created some partitions on the disk drive, created a file system, and mounted it as well. Viewed and created partitions on a disk and persistent file system mount points as well. Again, part of a more robust Linux series here. On the next video, we're going to go over logical volume manager commands. Can't wait to see you there. In the meantime, stay curious, stay secure.